Hey, how's it going? Alrighty. Let me just kind of walk through the code that we have written so far. Again, the goal here is to produce an application, a game with Python and using Pygame. Just kind of understand to see maybe the power of coding. So um, this is by no means something that I would expect you to be able to do on your own right now. Although if you did, that would be great. It's just me again, just if anything, showing you the power of coding and what you can do with it. So we are making a simple game. It's a snake game. If I play it right now, we'll see the little square move around. So not quite exactly how we want it to be, but it's getting there. So that's a good thing. Now, oh, I'm sorry, my phone here. Let me mute this. Okay, so let me just once again briefly review here what we've done. We've coded a few methods. We're calling these methods. It's just like a section of code that you just need to think of putting all this code in a method in a place where you can just run it if you need to. This is a special kind of method that we haven't discussed too much. It's called a constructor. It has to be called init, and notice that I have two underscores in it. And basically, what it does is every time you create a snake, like I'm doing right here on line 69, I'm creating a snake. Every time you create a snake, you're calling the snake S, but you could call it anything. Is equal to a snake. Notice that that comes from the name of my class because I've given this class a name. It will run all this code in this init method, which again is a constructor. And it basically what it does is it initializes all these variables. It says, hey, we want to set this width to 700, the height to 400, so on and so forth. The reason why we need to include this word self in front is because if you don't include this word self and you make the width of the window equal 700, and then somewhere in your other line of code, I don't see here where, so let me actually do a better example here. Here, for example, X, which is, I guess, where you're gonna, or I guess better yet, size. If I don't include that self.size, so if I just put size and I come down here where I try to draw my snake, my rectangle, remember that these are X and Y coordinates and then the size of the snake. And I don't include this word .self and I just put size and size. What happens is that when you are doing this, Python does not recognize variables across methods. So if I run this, I'm going to get an error here. It's going to tell me here that size is not defined. So on this line right here, on line 60, where I'm saying, hey, I'm going to make this snake 10 by 10. That's what size is going to be. It says size is not defined. And that's because it does not recognize these two variables, size in the main method and size in the init method. It does not recognize them to be the same. So I'm saying right here, I'm saying size equals 10, but Python will not recognize it unless you include this word in front, self. Now, again, there's a reason why this is the case. For us, right now, we just need to understand that we do have to include this word self if we want to use a variable in different methods. So that's the only place. That's the only place where you need it. Notice here, I didn't put self.snake. And the reason is because I only am going to use snake inside of the main method, and I'm not going to use snake anywhere else. Notice it doesn't show up anywhere else. And if I'm not going to use this variable snake anywhere else, then I don't have to put that self.snake, just snake. So I do that for any variable, all the variables that I'm going to be used in a different method. So I initialize all of them. I have this method, which is probably the harder one to understand, which is this helps us determine whether you've pressed on a key, the up arrow, the down arrow, the left arrow, the right arrow, or even the escape key. which is at the top left of your keyboard. That's what this does. This is a little more challenging to understand, but for us, for our purposes, just know that it works and that it's working good. Okay. Then we have this move snake method that basically checks to see if this variable move, if it's equal to right, then how are we gonna move the rectangle? Well, we're gonna increase its x coordinates so that it keeps moving to the right. But if move is equal to down, then we're gonna instead increase y, because going down increases the y coordinate. Notice how we have self.y is itself plus the step, how much we move. By the way, move is a variable that is set in the check keys method. This is detecting if you've pressed on the right arrow, and if you have, we set move to right. Now, all of that itself doesn't do a whole lot unless you run this code, which is where we are starting here. We're starting in the main method. Notice that on line 70, I have s.main. And so I'm saying that if active is true, notice that active is initialized to true here. When we first run when we first make our snake, it is set to true. And it is only set to false if we hit the escape sequence. And so if active is true, which again will always be true unless you hit escape, we're going to do this. This kind of slows down the frames per second so that we can actually see the square being drawn. We're going to fill the screen so that we can erase the previous square if there's one on there. We define our rectangle, x, y coordinates, width, and height, which is basically what we are using to model a snake. We draw the rectangle on the window with the snake color, and we update our screen. And then after we do all that, this runs all the code in check keys. So I'm going to write a comment here that says run code in check keys. That's what this does. We're running the code in there. And if you look once again at the code in there, it's basically checking to see if you've pressed any of the arrow keys or the escape key. And then after you run that code, then we run the code in move snake. And that is in charge of basically either increasing x or decreasing x, or increasing or decreasing y, increasing y, depending on whether move, the variable, is any of these. And it's not, move will not be more than one of these at the same time. It won't. It's going to be one of those. Again, that is initialized, or that is set in the check keys method. So we have how many methods? We have one, check keys, move snake, the main method, which is I guess where all of it starts, and the init, which is it runs at the very beginning when we first make the snake, and it initializes all these variables that we need. So just a quick recap of how this code works. Now, what I want to do next is I want to have the apple, and I say that I guess within air quotes because it's like, I mean, we could, I guess, maybe at some point transfer an image and have that show up, but we're just going to make a square of different color to represent the apple or the snack that the snake is going to eat. So let's go ahead and do that. First, I'm going to write it in here in the while loop, and then I can maybe move it into its own method. So how do I want to draw another square that represents the apple? Well, I'm going to take this because this is how we draw. Copy it, and then I'm just going to paste it here. I don't know if this is the right spot, but I'm going to paste it here. I'm going to call this snack, and I'm going to say here the snack will have the same size as the snake. That's good. It will not have the snake color. It will have a snack color. So it will be different, a different color. We'll be drawing the snack. And I clearly have a hard time typing the word snack. And then we don't want it to start right in the middle of. We don't want it to actually have the same coordinates as the snake because x and y are the coordinates for the snake. We don't want the snack to have those same coordinates. So what we're going to do instead is we're going to come here. For, as a matter of fact, I need to make this variable because I have not made this variable. So let me go up and make the snack color. I'm going to make it right after I make the snake color. And you can go pick the color that you want for your snack. I'll choose, my screen is blue right now, so a good contrasting color would be maybe light pink. 243, 124, and 249. 243, 124, and 249. So I have the snack color. Good. Notice that that is in the init method because all of this is initialized right when we first start our game. Kind of like that. I guess you can think of that's why this is init, initialized, sort of short for initialize maybe. So we have the snack color. Now, x and y are the x and y coordinates for the snake when we first start. We don't want the snack to be at that same location. So I'm actually going to make a new, some coordinates for the snack. I'm going to make them here as well. I'm going to call self dot, I guess I can say, snack x. X. Now I do want this to be random. I want the snack to show up at some random spot. So if you remember, to make a random variable, we use random.randint, and then we specify from where to where. So I think the smallest x coordinate for the snack can be 0. The biggest x coordinate would be 700. And then self.snack y equals random.randint, and then 0 and 400. Now, obviously, I don't want to put 700. Instead of, I'm going to use self.w and self.h. But I do want to make a note here, which is, if the snack, when we specify its coordinates, it's the corner, the top left corner. So if I do 700, 400, the snack would actually be right here. Let me actually draw it. It will show up right here because this coordinate, that is 700, 400. And so what I want is, at most, I want it to show up here. And so basically I want to subtract the size here. So notice that, again, that's kind of like 10. And from 400, I want to go up 10 so that this is 690 to the right and 390 down. And how do we get this? Well, we get the width and subtract the size of the square, and right here we take the height and subtract the size. Again, the size is 10. And so I'll come in here and I'll say it's going to be the width minus self.size, and the height minus self.size. I'm going to get an error here, but I want you to see why I get the error. Well, first I need to import random. So I'll put it here, import Pygame, and then comma, and random. Notice here, it says snake object has no attribute size, and its issue is right here with this, which I just wrote right here. And that's because I'm trying to use this variable called size. I'm trying to use it before I declare it on line 15, which means that this right here actually has to be moved below. And you can highlight and then drag down, and it kind of moves it down. This needs to be a new line there. So first I need to specify what size equals, and then once Python knows what I'm setting size equal to, only then after that can I use it in my calculation. Okay, so this makes a snack at some random location. Let me see. I should see it. I don't see it, right? Let me do it one more time. Again, I don't see it. Let me just verify that my draw. So I have my snack. Oh, that's because this should say self.snack x, and then this should say self.snack y. That's right. Okay, I still don't see it. Let me see here. Let me try to see if I put it before this update command. That's probably why I'm not seeing it. Okay, it's having problems here with something. Let me see here. Oh, that's because this needs to be on a new line. Okay, make the snake, draw the snake, make the snack, draw the snack, update my display so that I can see them. Okay, it's there. If I run it one more time, it should be at a different location. Yeah, it is. Look, it's over here now. That's because it's every time when I first run my code, it makes a random number for the snack, for the X and Y coordinates of the snack. But it's showing up. That's good. Okay, that's good. Now, what we want then to do is we want to basically make the code that is going to detect whether the snack and if the snack and the snake are at the same location. I want the snack to disappear, and I want to basically draw it at a new location. So I'm gonna do the following. I'm gonna make a check here. I can do it actually after I'm gonna do it over here, and then we'll see here. Before I check the keys, I'm gonna say if the snack and the snake have the same location, and we can do that doing the following. If self dot, you know what? Let me do here. I'm gonna make this variable called delta x, which is basically what I get when I subtract the x coordinate, which is the location of the snake, minus the x coordinate of the snack. Now I do want this to be always positive because sometimes it might be negative, and I'm not interested in negative values, so I'm going to put here absolute. And I'm going to do the same thing for y. Delta y is the difference in the location of the y coordinate for the snake minus the y coordinate of the snack. I'm going to say that if this is 0, meaning if you subtract the x coordinates for the snake and the x coordinates for the snack, if you subtract them and they equal 0, that means they're at the same location. So I'm going to say that if delta x is less than, if I put equals 0, let's try, and delta y also equals 0. If that's true, then what I want to do is I want to create new coordinates for the snack so that it shows up at a different location next time it's drawn. Snack x is equal to, I'm actually going to copy this right here. Let me just copy this because I can use this. So if delta x and delta y equals 0, which means that the x coordinates are the same, that's the only way this will equal 0, which means that they're at the same location. I want to create a new x and y coordinate for the snack so that it shows up at a different location now. Let me try this. I actually foresee here a problem, but again, I've coded this in the past. And the problem is that you're going to have to get it to be right on top of the snack. And you want to give yourself a little bit of cushion, meaning like you get close to it, it should go it should disappear. Let me do this. Instead of making it less than or equal to 0, I'm going to say that if delta x is less than a step, which is 10 pixels, that's how much you can move every time you hit the air. Every time this loop goes a new iteration, we are moving 10 pixels in any direction. So I'm going to put here if they're less than the step that we're using, then I want the snack to show up at a different location. There you go. You see how it kind of simulates you eating the snack. There we go. Now, as long as they get pretty close to each other, it shows up in a different location. Now, if you want it to be like even more, like notice there it's hitting it, but if you this is 10, by the way. If delta x is less than 10, if I make it less than 20, then you're giving yourself kind of like more cushion, and so you just need to get kind of somewhat close to it now. Notice how I didn't even touch it at that time. So the bigger this number gets, the less sensitive it is in terms of you being right on top of the snack. The smaller it gets, you have to like right on top of the snack. So I'll leave it at 10. Okay, now again, we have some code here, and I think this is code that is carrying a specific purpose. It's basically detecting whether you've eaten the snack, and if you have, it creates new x and y coordinates for the snack. So I'm gonna put this in its own method. I'm gonna cut it from here. I'm gonna just maybe make it right here after, no specific order. What actually, I'll follow the order that I have here, which is, I'll put it up here. I'm going to find this new method called collide. So it's basically checking to see if the snack and the snake have collided. And then I'll put all that in there. So check the difference between the x coordinates of the snack and the snake. Check the difference between the y coordinates and of the snack and the snake. If they're less than 10, if the difference is less than 10, that means they're very close to one another. So create new x and y coordinates for the snack. And I'll just execute the code here. Self collide. You can call it a different name if you want, but it's detecting, I guess, in essence, a collision. And again, what we're doing here is we're running the code in collide. Let's just run it to verify all this is working fine. Almost got you. You can see that I'm not good at this game, okay? There we go. It works good. I should probably slow the speed down, right? Because this is going too fast for me, it looks like. Okay. Good. In the next tutorial, we'll keep going here and work on actually increasing the length of the snake.